one question that comes up here a little bit is how much of this research has been done on females and different ages, different life stages. I know again, this is an opinion that I've seen out there and has been shared with me by a lot of people. So I'm not getting you to comment on the opinion so much, but more your sort of feel for the evidence that exists out there and where you land. But there is a doctor that has been sharing information online stating that the TRE studies haven't really included many women sort of aged 40 and over, I believe, and that she doesn't believe that time-restricted eating is kind of healthy for women of that age. How do you sort of feel about that?
Again, that's an opinion, and it's good that we have to include more women in studies, and we got to see whether they will benefit or not. But the animal studies have again shown that both young, middle-aged, and also a little bit older female animals still benefit from time-restricted eating. In fact, in animals, time-restricted eating extended their reproductive lifespan. So that means these animals were still ovulating at an older age when the leaf-fed mice have stopped ovulating. And then in our studies, what we have found is female mice who were eating within 9 hours, they were completely protected from endotoxin shocks, which is similar to bacterial infection. So in our study, what we found is male mice that were ad libitum fed, nearly half of them, more than half of them died when they're challenged with endotoxin shock, and nearly 1/3 died when they did time-restricted eating. The female mice, on the other hand, all 100% of them were completely protected. None of them died if they had done time-restricted eating. So that's again another example. Means people always, people are stuck with this idea, their personal opinion and their conviction, and the thing that, okay, women cannot lose weight, older women, and it will not help. But the thing is, people have to be a little bit open-minded. And then, it's a good question to ask that, yes, there should be more women in clinical trials. And in fact, there are in many of our studies also, we have included women, but I must say that the number is not large enough to do statistical analysis on individual gender and then figure out whether it's good or bad. What we have seen is many women, they want to try all at the same time. And they also want to get most out of it. So then what they end up doing, they'll try to do 4 to 6 hours of time-restricted eating. So they are fasting for 20 to 18 hours. They want to reduce calories significantly. So the only thing they eat is salad and a few other nuts or something. At the same time, they want to run a marathon. And then what ends up happening is they are more likely to become amenorrheic, and more likely to have low bone mineral density and brittle bones. And that's what happens. And it's actually, there is a syndrome called relative energy deficit in sports.
Right.
And Reds is more prevalent among women, but also there are many men who succumb to Reds. So we have to keep that in mind, that maybe some people took it to too extreme, and they are the ones who might have suffered. And it's always those few anecdata that complicate the field.
You mentioned there the kind of mice studies that have had male and females, and I think some people might be thinking about the kind of reliability of translating findings in that research to human research. And I know that you're a big proponent of multiple lines of evidence, but just with regards to circadian biology and thinking about hours, is the circadian clock in a mouse, because I think we kind of glossed over this, but is it similar? Is it a 24-hour clock, and thus those eating windows in those experiments are quite easy to kind of translate to human eating windows as well?
Yeah, the clocks are very similar, and in fact, most of the clock genes and the mechanisms are identical or well conserved between mouse and humans. Metabolism, we all know that there is some differences. So, for example, 14 hours fasting in mice maybe a little bit should be equivalent to more longer fasting if we just think about if you're thinking only about glycogen depletion or fat oxidation. But many circadian based parameters. So, for example, when I say gut repair, or there is a time window within which the gut has to repair, or there's a time window in which the insulin producing cells are more active. All of those mechanisms are very similar between human and mouse. So that's why we have to keep that in mind that, well, there are some aspects of metabolism, those are different, but when it comes to repair, rejuvenation, reset, these are very similar. I'll give you an example. How much do you think a mouse, little mouse that is 30 grams, that weighs 30 grams, runs every night? How many meters or kilometers you would think?
Oh gosh, a little mouse.
Little
I'm gonna
mouse,
say
only-
I'm gonna guess 1.5 kilometers.
a mouse can run somewhere between 7 to 12 kilometers every night.
Gosh.
So that means I should run between here and San Francisco every night if I extrapolate that. But that doesn't extrapolate that way linearly. Many things don't extrapolate linearly. So in that sense, yes, as the animals are smaller and smaller, they actually have different metabolism. Just think of the hummingbird, how much it has to fly to get tiny nectar. So in that way, there are differences. But when it comes to circadian rhythm or circadian related stuff, then there are similarities. In fact, a few years ago, we did a very simple experiment. We asked, does the benefit of time-restricted eating depend on circadian clock, which is a very counterintuitive experiment to do from my lab because we always think of circadian rhythm. But what we found is, yes, it does actually benefit even mice that don't have circadian clock because of genetic defect. And the reason is this, why we did this experiment. There are many genetic models of mice and laboratory animals that also succumb to similar metabolic disease as humans do. And as genetic testing is becoming more and more widespread, we often blame it on our gene. We say, hey, I'm diabetic because it runs in my family. I cannot help it. But actually, the point is, if you have a faulty gene, then you can adopt good lifestyle to reduce the adverse effect of that faulty gene. And this is very important when it comes to a healthy lifestyle. The healthy lifestyles are actually something that we can do to address our faulty gene, because we cannot change our genes, but we can change our lifestyle. And when we change our lifestyle, we can significantly reduce the risk for many diseases. So that's why we did the experiment. But the bottom line is, yes, even time-restricted eating can override faulty genes that make mice obese, diabetic, or even have cardiovascular disease.